right, I want us to look at a pattern first to be able to better understand negative exponents, okay? So we all know that 2 to the third power equals what? 2 times 2 times 2, which is 8. Good. We all know that 2 to the second power equals 4. We've talked about this one also. 2 to the first power equals 2. What happens each time to these values over here? Okay, it gets less, but by how much? What's the pattern happening? So we're taking half of it. They're dividing by 2. So as the exponents decrease by 1, 3, 2, 1, we are taking half of the value. So if I said 2 to the 0 power, what's half of 2? 1. So that's why 2 to the 0 power equals 1. If I say 2 to the negative first power, what is half of 1? 1/2. And if I said 2 to the negative 2 power, what's half of half? Very good. Half of a half is 1/4. Now we could keep going, okay, but we don't need to. I just wanted you to see where these numbers were coming from, okay? Each time you decrease a power, you're taking half of the value. All right, so a 0 exponent for instance, if you have 5 to the 0 power, it's going to give you a value of 1. No matter what your base is, if you have a 0 for the exponent, the value is a 1. So your base might even be a variable. Even if your base is a variable, the value is 1. Okay? And that'll be always. Now for your negative exponents, there's a trick that you can do here. Instead of making that chart like we just made with our Tues, we'll be able to do a trick that always is going to work for us. So again, this is going to be our negative exponents. I'm going to tell you that 5 to the negative 2 is the same thing as 1 over 5 to the positive 2. So this is my rule. Move the power to the denominator and the exponent becomes positive. Move the power to the denominator. Move the power to the denominator, and then it becomes positive. Move the power to the denominator, and it becomes a positive exponent. So this works the same way if you have a variable, like if you have m to the negative third power, and we wanted to write this so that we did not have any negative exponents, this would be 1 over m to the third power. So we're just taking that whole power and moving the whole thing down to the denominator, which changes the sign of our exponent. So we're going to do some practice with this. We're going to write the expression using only positive exponents. And that's kind of what these two are right here. Writing the expression using only positive exponents. If you had 3 to the negative fifth power, think to yourself right now how you would write that so that 5 became a positive 5. Anyone want to say how they would do it? Tommy? There you go. A That's all you have to do. Now, I'm not asking you what does that equal. You're writing it with that exponent still. We don't have to do 3 times 3 times 3 times 3 times 3. Okay? We're leaving it just like that. This works the same way if we simplify x to the negative 6, y to the 4th. So in this one we have like two separate things. We need to think about our x, we need to think about our y separately. So the x has a negative exponent. So to make that negative 6 a positive 6, we're going to do what? We're not adding anything. No. I want you to think of this as two separate problems. How would you write that so it has a positive 6? Okay. And this would just be, it's already positive, right? So it stays the same. So again, you're thinking of this as separate things. X to the negative 6 is going to move to the bottom and become x to the positive 6. And y to the 4th stays the same, so it stays on top. We're not multiplying and dividing them. You can't do that unless the base is the same. These are not the same letters, so we can't multiply or divide anything, or add and subtract anything. They're not the same base. So it's separate, kind of a separate problem. Let's do another one similar to that. Let's say we have a to the 4th power, b to the negative 7th power, and c to the 0 power. So again, I want you to think of three separate things here. What am I going to do with a? What am I going to do with b? What am I going to do with c? So since a is positive, does it go on top or bottom? Do I have to do anything with a? It doesn't need to change, correct? A to the 4th doesn't need to change, does it? So it stays on top. B needs to change. B has a negative 7. So if I move it to the bottom, it becomes a positive 7. What does c to the 0 power equal? 1. So technically, this is like saying times 1. But anything times 1 is itself, correct? So to simplify this completely, that 1, we're multiplying by it. It's gone now. This is it. We don't even see a c, CAC, in our answer. Let's do another one similar to this one. Let's say e to the negative 8th power, f to the 6th power, and g to the negative 3rd power. So think about, is it going to go on top, or is it going to go on bottom? Alright, what should we do with e to the negative 8th power? I need to make it a positive, so where do I put it, top or bottom? Bottom. So it's negative, so it's going on the bottom, so it becomes positive. F to the 6th power. I don't need to do anything to it, so it stays on top. G to the negative 3rd power. It needs to go to the bottom, and it changes. So again, anything, if I lost anybody there, these are negatives. We don't want them to be negatives. So we move those two to the bottom, and their exponents become positive. But f is fine. So it gets to stay on top, and it stays the same. Okay? But if we change it to the bottom, that sign on the exponent changes. What if we had... So your 16 is separate from m. You have a 16, You have an m to the negative fifth power. You have a y. So again, the only thing that gets moved down to the bottom is something that has a negative exponent. So the only thing that has a negative exponent is the m. So the only thing that's going to move to the bottom would be that. And because we're going to move that m to the bottom, that negative 5 is going to become a positive 5. The 16 and the y are fine. What is the variable, or excuse me, what is the exponent that is on the y? 1. Okay? No. I didn't say it becomes a 1. I'm saying this is y to the first power. So it doesn't equal 1. Y to the 0 power equals 1. Okay. This m is what moves down. Did you? How about a to the negative 7th power, b to the negative 5th power, c to the 4th power, d to the 0 power? Probably thinking, oh my gosh, what is she asking? So you have 4 different things here. Think about what goes on top, what goes on bottom. Alright, so looking for those negative exponents. A has a negative exponent, B has a negative exponent. Those other two do not have negative exponents. So anything that has a negative exponent, we need to move to the denominator. So that becomes a to the 7th. This becomes b to the 5th. C to the 4th is fine. Leave it. What happens to d to the 0 power? Turns into a 1. D to the 0 power equals a 1. So that's like saying times 1, which we don't really even need there. It's not wrong if you have it there, but you don't really need it there, okay? So really your final answer would just be that right there. You should not see a D in your final answer. There's no D in the final answer. Okay, I feel a little bit better about how you feel about that. So now we're going to try doing the opposite. We're going to do the opposite, okay? So we're going to write this using, without a fraction bar. Write without a fraction bar. The first thing that you're going to do, if you have a number, is you're going to write the prime factorization of the numbers. Here's that prime factorization. Then, any powers that you have in the denominator, you're going to move them to the numerator, and the exponent is going to change to negative. Move all powers in denominator to the numerator. And change the sign of the exponent. Alright, I'm going to pause this so you all can write the... Alright, so let's do some examples of these two steps. So if I wanted to write this number without a fraction bar, the first thing that I would need to do is write the prime factorization of 16. So 16, that's 4 times 4, and 4 is 2 times 2. So that'd be 2 to the 4th power. Do we all agree that 16 is 2 to the 4th power? So this equals 1 over 2 to the 4th power. So we take the power that's in the denominator. So my power is 2 to the 4th power. And I'm going to move this power up to my numerator. And when I do that, the sign of my exponent changes. So it's a positive 4 right now. So it's going to change to a negative 4. So again, the 2 to the 4th power was in the denominator. I moved it up to the numerator. So now it's a 2 to the negative 4. And if someone needs to see that even more clearly, maybe me writing it like this would be more clear. That you're moving this up here to the numerator, but we really just write that. We don't need to write it over 1. That's why I just wrote it like this, okay? Maybe that makes it a little bit easier. What if we had 1 over 27? Will you figure out what the prime factorization of 27 is? The 9 is not prime. So the prime factorization of 27 is 3 to the 3rd power. So this is 1 over 3 to the 3rd power. Again, we're moving this up to the denominator. So it's going to be 3 to the 3rd power, negative 3rd power over 1, which would be best written as just 3 to the negative 3rd power. Alright, I think I'm going to stop here for today to kind of let some of this sink in, okay? And then tomorrow, we'll review what we talked about today, and then there's more that I want to tell you, and then you'll have time to work on your assignment in class tomorrow. That way that you can either ask each other for some help or ask me for help, okay? So again, we're just going to stop here and let this sink in for a while.